Hello, manufacturing world. I'm Wade Anderson with Shop Matters, sponsored by Okuma America. This podcast is created to discuss all things machining and manufacturing. Today in the studio, I've got Dan Parry with DP Technology and Bill Cox with Renishaw. Welcome, guys.
Thank you, Wade.
Yeah, it's a sunny, beautiful day here in Charlotte, North Carolina. So just wanted to spend a little bit of time with you guys here today in the studio. Dan has joined us before for a podcast, but Dan, just for those who may not have heard it or don't know who you are, I would say that you are like the brainchild of everything knowing about Esprit. Is that a humble way to state that?
I don't know. I don't know about all that, but I definitely, I bleed red, I guess you could say.
All right. So tell us a little bit about DP Technology, what you do, what your role is.
Okay. So I'm the Eastern Applications Manager, and basically that means that I'm in charge of the applications team here in Charlotte. There's about 10 engineers that do various things from customer support to part programming and just all kinds of engineering services type of work.
Okay.
And
how long have you been with DP Technology?
So going on 10 years now.
10 years. All right.
Yeah.
Good to see some longevity, right?
Yeah.
So this, the way we're set up kind of feels like an interrogation. So it's like you guys against me or no.
Right.
So Bill, tell us a little bit about you, your background, what you do with Renishaw, how long you've been there.
Okay.
How many kids you have.
All the good stuff, yeah. I'm district manager for Renishaw. I manage the southeastern United States, which covers about 14 states. Mm-hmm. We have 6 sales engineers within the region. We have several more application engineers. We also have an EDU engineer who's basically handling our training and all like that. And all those people are based out of the Piedmont, Carolinas. So my length of time with Renishaw, I've been with Renishaw 24 years. Before that, I was selling through distribution for Renishaw for another 7 years. So I've got a connection with them over 30 years.
Wow, fantastic.
My background before that was in cutting tools and abrasives, machine tools.
Okay.
And metrology.
Okay.
So, like a lot of people that got in this industry, I didn't study engineering. I basically came through it from a sales perspective and then got into an engineering perspective. But
okay.
Renishaw itself's been around for about 40 years, and we were the creator of touch trigger probing. So,
okay.
Yeah.
So tell us more about Renishaw, the products, and what does it do for the customer? So you just talked about touch trigger probing.
Right.
What does that mean? If I'm a shop guy listening, I think pretty much everybody that's in manufacturing is going to know Renishaw, but just give us some background anyway.
Right. The background of the company, the creators of the company, Dave McMurtry and John Deere, were engineers at Rolls-Royce, and they had a problem they needed to find a solution for. At that time, CMMs had a hard piece of metal as the probe. It didn't give a response. You basically just moved the CMM in 3 axes and then took a trigger point. They had very flexible, they were working on the fuel portion of the supersonic jet. So they had to come up with a device or a method to measure flexible fuel lines. And McMurtry, over a couple of weekends, came up with the electronic touch trigger probe, and that's where the company started on the CMM measurement side. Well, we went forward. Our products basically grew organically. So from CMM probing, we went into machine tool probing. With the advent of machine tool probing, we had to understand the basics and the construction of machine tools and know how does that affect the probing and the application that we're looking to achieve. So we came up with calibration devices so that we could determine what was the current status of the machine tool, the condition. In manufacturing, you have events that happen in a shift before you're engaging on the next shift, whether it's a crash or there was a wear event that wasn't taken care of with tooling, or temperature events that were going on with the transition of temperature from evening to morning and all like that. So
I think that's an interesting point. I think of, from a machinist standpoint, using Renishaw probes to find my work offsets, inspect parts, things of that nature.
Right.
But there's a big component of where we use Renishaw in the actual machine calibration standpoint. And
correct.
verifying what you start with has got a solid foundation and then grow into the cutting process. We even use it in building machine tools, right? You guys have laser calibration systems.
Yep.
Talk briefly about some of that from, I guess, like the genesis of a machine tool being built and using your equipment, and then actually on the shop floor in cutting processes.
Yeah, I mean, when the people like Okuma and OEMs like them are building a machine tool, one of the basic things is qualifying the linear accuracy of the machine tool. Mm-hmm. You have linear encoders, but you have variation in encoders and things of that nature. So laser interferometry is used to validate and to report the current condition of the machine tool. So in the building process, you'll shoot it with lasers. You'll verify it. You'll put in offsets into the control that will compensate for any minimal changes within the encoder system and all like that. Mm-hmm. So that gives you a basic baseline of the machine. Now, that's a process that you do during the build or periodically in the manufacturing plant. You might do it yearly, whatever, to as part of the annual maintenance. Mm-hmm. The other part of calibration is determining the current conditions on a daily basis, and that's where a device called the QC20 ball bar is used. Mm-hmm. It takes about 5 minutes to run. You can see conditions that have occurred on a previous shift or in some cases, let's just say plants in Texas may have a broad variation in temperature from evening to morning. So you have machine growth. You have growth in other components within the machine, the tool holders, whatever. So using a tool like that allows you to verify the current conditions of the machine tool and make corrections. Okay. Whether it's in work offsets or different things like that. Okay. Then you step into the probing aspect, which is process control.
Right.
Yeah.
We used to use probing back many years ago when I was cutting chips on horizontals. We'd put tooling balls on fixtures.
Exactly.
Different locations. So we'd run a new job in, come in, touch a tooling ball in 3 different locations. We'd quickly see what's my parallelism, what's my straightness, is my B-axis. We'd probe it, with a certain angle so we knew if something was off. We had a certain set of work and process parameters that we would run to, and if any of those variables were too far out, we'd flag the machine to stop or call, so we could catch, did somebody wreck it the shift before or something like that.
Yeah, basically artifact comparison is what you're doing. You've got a qualified ball that's on a mag base or whatever, and you're just going in and taking various measurements around the spear of the ball.
Okay. So we talk a lot about the process inside the machine and probing parts during the manufacturing segment. In high volume type applications, though, a lot of that inspection is done outside of the work envelope.
Correct.
With, as we talked about, closed loop machining, Industry 4.0, IoT type, as revolution in technology moves forward, how do you guys address that side of it? Is there products, is there technologies that we utilize the OSP control on? What does that look like for manufacturers?
There's hardware and software involved. Okay. Outside of a machine tool, such as lathes or grinders, where you've got high throughput, you don't have you've got time constrictions on doing anything like probing inside the envelope. Mm-hmm. We use a device called the equator, and the equator is a comparative gauge. Very fast, very precise. Uses CMM technologies integrated with your basic comparative type measurement, which is, most people look at a comparative measurement as fixture gauges.
I hear that referred to like a shop floor CMM.
Right.
Is that a fair statement?
It's a fair enough statement. It's not a CMM, and we use the comparative method because we don't have an error map on there because we're going precisely to the envelope of the part, not the full envelope of the unit itself.
Got it.
So we integrate the equator. Again, I mentioned it was very fast, and it's much faster than a CMM. So we're able through our basic measurement cycles that we would use for process control inside the machine. We use similar, the same, or even more complex measurement cycles, but doing them very fast, feeding that data back through a Karen AutoComp or whatever to the Okuma OSP control.
Okay.
Doing work offsets in that manner. That way, we're able to do compensations on the fly. Minimize scrap parts because of issues that have come up. Along with that, there's the Revo technology, which is 5-axis CMM technology. So when you actually want to have a CMM on the shop floor, it can't be a bottleneck. What Revo gives you is 5 to 10 times faster measurement on a CMM while maintaining the accuracy.
Okay.
Okay. So we're looking at either measuring inside the sheet metal or outside the sheet metal, but we're still trying to control the process.
Okay.
Okay.
How does the spree tie into that, Dan?
So the way we tie into it, probably there's several ways. I guess you would say probably the biggest one is with our probing functionality. So we have a completely integrated probing solution inside of a spree that allows the user to not only create the cycles that they need for in-process gauging and locating work offsets and things like that, but also for outputting the necessary code for those statements. And by having it as part of the user interface, they can not only validate the program, but also have collision detection and know exactly what the probe inside of their machine is going to do.
Okay, very good. As we talk about process control, any new technologies? What's Renishaw working on? What are you doing right now? What's the next 5-10 years look like?
The next 5 or 10 years, the repeatabilities of the probes, we call it repeatability because the full system would be accuracy. So let's just look at the combined aspect of it. The accuracy of the probes are getting more finite with strain gauge probing that we introduced several years ago. Now, I will say Okuma basically has been the leader in the use of strain gauge probing on their applications from us. Basically, just allowing your customers to have a more refined accuracy and repeatability in their applications.
Okay.
So we're also getting into where those are considered touch trigger probes. With our sprint probing systems, we're getting more into analog probing where you can actually scan parts. More applicable towards larger, more expensive parts in relation to what people are trying to do towards adaptive machining.
Okay.
But that technology is progressing. One of the things that the transmission systems, normally you only have so much bandwidth, so whether it's optical or radio, so we had to wait for certain technologies to advance.
Sure.
Where it put us into a position where we could take advantage of analog because you're taking a large amount of points, whereas with touch trigger, singular points, you're doing a lot of math to coordinate what you're trying to achieve. But so that's next generation things that are here now.
Okay. Excellent.
Yeah.
So Dan, I've been talking to Bill the whole time here. Let's pull you into the conversation.
Okay.
I know you do a lot with Partners in Think and Okuma in terms of events and showing new technologies and demonstrating different ways of manufacturing. Tell us a little bit about what you're going to be working on as we roll into the new year.
Okay, so yeah, we do a lot of events, and the reason why we do this is to to show our customers that we're out there, we're thinking for them, we're there to support them and bring them the latest innovations in order to help them be more productive in whatever they're doing. So as part of that, I think one of the things that all the shops out there are feeling is a lack of skilled labor in the workforce. And that being said, we've been brainstorming on different ways to be able to help our customers come up with better methods for being able to account for the loss of skilled labor in the workforce. So for 2020, we're going to do a lunch and learn series with Renishaw and also Cairn Engineering and Kennametal. Now, a few years back, actually back in 2013, we did a much less sophisticated version of what we're going to be showing. But really what it revolves around is closed loop machining or closed loop inspection.
So you hear a lot about that in the marketplace right now, closed loop machining, letting the process itself have the intelligence for the manufacturing side. So talk us through, what does that look like?
Exactly. So basically the way it works is we're going to, we have the key partners who all have, technology that is very vital to this process. And it basically starts with, machining a part, putting features on a part, and then, using an Okuma machine for this technical seminar. And then basically Renishaw will come in and do some in-process inspection on that part, measure bores, bolt circles, whatever we choose to measure. And based on that feedback from the probe, we will then make decisions during the process about what needs to be adjusted, if anything. And that's where Karen Engineering comes into play. So they have their AutoComp product, and that will basically allow us to automatically compensate tool wear offsets and be able to make decisions about whether or not any remachining needs to be done.
So taking that decision making out of the day-to-day or minute-by-minute shop floor operator, and again letting the technology be able to make those decisions.
Yeah, exactly. I mean, the operator should never have to touch anything in this scenario with the closed loop process, because the last piece of the process is the ROMicrom boring system from Kennametal. So in this particular example, we'll be boring a certain diameter, and then the ROMicrom system has a knurled ring on the end of the bar that allows for adjustment.
Okay.
And that ring has some dowel pin holes in it. So inside of the machine, we will locate a dowel pin, which is part of this ROMicrom boring system, and then we'll program the machine. In the case that a bore needs to be adjusted, we'll program the machine to execute that call statement and go over to the location where the pin is, lock in on the pin, and then use the C-axis to adjust the boring bar. Every click is about 2 microns. So,
Oh, wow. Pretty fine adjustments then with that, even for a kind of a mechanical type setup.
Exactly, really fine adjustments. But so we'll have it all figured out, to be able to know how far we have to adjust the C-axis in order to achieve the diameter that's necessary based on the inspection that we did previously. And that kind of ends our loop. That's the end of the loop, is deciding what needs to be adjusted, making those adjustments in the machine without any operator interaction, and then remachining, and then the process starts again.
Okay. So after the remachining, you would inspect it,
Right.
verify we wanted to move 5 microns. Did we get what we set out for?
Right.
Okay.
So, I mean, you're
Excellent.
basically controlling the process in a new manner.
Okay.
Yeah.
So how often will you be doing these, and where? Are they going throughout the tech centers at Okuma?
Yeah, so typically that's what we do. We'll normally pilot the first event here in Charlotte, and that's usually going to take place in January, February timeframe. I think right now we're tentatively scheduled for either the last week in February or the first week in March, but we'll be sending out email blasts and with some concrete dates when we have them. But the first event will be done here in Charlotte, and then usually we'll take it to one of the other 2 tech centers, either the one in Houston or Chicago, and do that one. And then we'll pretty much always get all 3 tech centers, all 3 Okuma tech centers, and then we'll take it to the distribution network.
Okay.
So we'll open it up to any distributors that are willing to do it. And this just allows us to cover a lot more ground and, bring these new ideas and technology to customers all over,
Okay. So Bill, if a customer's out in the field and trying to solve a manufacturing problem that he's got, wanting to do more with gauging, what's the process? How does he get in touch with you or somebody from the team at Renishaw to come in and look at what he's doing?
Well, now it's multiple ways. We have a lot of internet traffic now, which we're all involved in now. It's not the old-fashioned dial up the salesperson. Well, we do have a lot of that, but so basically, we on our website we have where customers can go and describe their application and inquire about and ask for an initial contact.
Okay.
Or they call the regional sales manager direct, or they can call me direct, or any of our engineers. So we're still very accessible. The great thing we've done in recent years is we've done outreach now. So instead of having a lot of our technical support come out of Chicago, we've placed it in the field. So in my territory, we've grown by 8 people in the last 4 years.
Okay.
Instead of having them come out of Chicago, we're putting people out in the region. So we've done that in the Northeast, the Southeast, the West, and the Central area of the U.S.
All right. Dan, what's the best process to get in touch with somebody from DP Technology or Spree if a customer's looking at trying to solve future manufacturing needs?
Well, for us, obviously there's multiple ways. They can use the Esprit web. So the Esprit web is kind of tailored to each user, so they could actually submit their own incident if they wanted to, or they could call our 1-800 number on the website, or just email support@dptechnology.com. But I mean, this is one of the ways that we differentiate ourselves in the marketplace, is by providing a level of support that is really just unrivaled in the CAM industry, especially. We have engineers on support full time. There's engineers in each office, so we cover, on the East Coast from 8 in the morning until 8 at night, and most of the time with our engineers, even if you had to send an email outside of those hours, you'll get a response. But yeah, we have really strong coverage as far as customer support is concerned, and we want to support our customers in all their endeavors.
All right. We look forward to the event. I can't wait to see the first one roll out, and I appreciate you guys joining us in the studio today. Until next time, this is Wade Anderson with Shop Matters. If you guys have ideas, any thoughts that you want to explore on podcast series like this, reach out to us. Till then, we'll see you next time.